Hello guys, so in this module we are going to discuss about the valves and cocks. Okay, so as you can see on the screen, we have got this number 3 section which is talking about the valves and the cocks. Okay, so let us go into the details of this section.
To every marine engineer out there, from junior engineer to chief engineer and electrical officer, we all know that earning respect on ship is very important. We all know fast promotions are very important, and we all know that इज्जत कमानी है, promotion चाहिए तो काम आना चाहिए, तो जूते पड़ते हैं, गालियां पड़ती हैं, and for that you need a good mentor. Sometimes we keep finding those mentors on board ship, अगर नहीं मिल रहे तो MNDFLIX है ना, Merchant Navy Decoded has launched a subscription model where you can find more than 30 plus courses with respect to your rank, helping you earn respect on ship. Please enroll on these free trial videos, watch these videos as per rank, and then decide whether you want to invest or not, with a very good flexible payment plan as well. Jai Hind, Jai Bharat, Jai Mata.
Okay, so number one is a stop valve globe. Okay, so first thing we will see what do we mean by stop valve. So as we can see, any valve which is a globe valve will be denoted by this symbol, plus if you have a T on the top, that means it is hand operated. So this is a manually hand operated globe valve which is linear flow, having a linear flow. Okay, so uh, stop valve basically means any valve which is normal globe valve which is closed by human operation. So when you manually close or open it, that will become a stop valve. So if you see the diagram, uh, this is a this is an angle valve, angle globe valve. Just I have taken it for reference. Since it has got a wheel and a spindle, you can open and close it by hand operation, so it becomes a stop valve. Okay, so stop valve angle, which is the second one. If the flow is linear, it is normal stop valve globe, it is written globe. And same other one is also globe valve, but it is written angle because it is the flow direction is perpendicular to the suction, to the inlet. Okay, outlet is perpendicular to the inlet, so that becomes a angle valve. As you can see, this is the angle valve. Flow is from one direction and it is going out in the other direction. So it is written 10K20. So question for you guys, what is 10K20 in this uh, valve written? Okay, and you can see the flow direction also is made on the valve. You can see this one here. The flow direction is made somewhere like this and it is going in this direction, so that you do not mistake while fitting it uh, on the flanges. Okay, so 10K20 refers to, so 10 is referring to the 10 bar pressure that this valve can handle. So you will use this valve only up to 10 bar pressure areas. Okay, you cannot use it at 16 bar or something other, because the valve is not designed to handle that pressure. And 20 is your 20 centimeter nominal dia. Okay, nominal dia, I will come to this, what is a nominal dia and etc., when we are discussing the pipe standards. Okay, 10K20. Okay, now come to, so stop valve, we are clear. Stop valve is normally manually operated valves. Okay, three-way valve. So we can see in the photo, if you find the valve like having three triangles and connected with a T, that means it is a three-way valve. The operation can be manual, can be automatic, can be spring loaded. That depends on the type of control that we had seen yesterday. Control can be hand operated, can be spring operated, can be weight operated, or any by that matter, float operated, piston operated, diaphragm operated. So these are all controls for operation of these valves. Here in this picture it is shown a three-way valve with a hand operation. Okay, hand operation. Three-way valves just mean that the flow can be in all the three directions, can come from one side or and can go either in the 90 degrees angle or can go in the same linear flow direction. So basically when we are using three-way valve, your recirculation lines or the bypass lines will have this type of three-way valves. For juniors, fourth engineers, the recirculation line in the purifier, very very important, is the three-way valve. You can see a photograph of this. This is a three-way valve connected in the jacket water system. So whenever you need to control the jacket water flow, you bypass the jacket water. You can see it is connected to the cooler, so cooler is bypassed accordingly, the as per the requirement of the uh, say system. So if you are needing the water to go through the cooler, it will go in this direction. If you don't want to go it to through the cooler, it will go in this direction. Okay, it will bypass. So this valve is a three-way valve. This is automatically controlled. You can see there is a control mechanism installed on top of this valve, which is remotely connected. So from the controller it is being controlled as how much is this valve required to be opened, depending on the sensors input, how much is the actual jacket water temperature right now. So accordingly the valve will bypass or will flow through the cooler. Okay, so this is the bypass and this is through cooler. Okay, take a different color for this. This is through cooler. Okay, and this is bypass. So basically this is a three-way valve. Design aspect, control aspect can be different, but the mechanism is same. It is actually using a bypass mechanism. So the flow should have been from one direction to the other direction. If it would have been a normal stop valve, it would have been in this direction, but since it's a three-way valve, you have got a different direction also to let the flow. So this is a three-way valve. Okay, now coming to next, that is a lift check valve. Okay, lift check, and whenever you see this word check valves are called the non-return valves. Non-return valves. Okay, so wherever you will see this word check valve, that means either lift check valve, screw down check valve, swing check valve. All these check valves are non-return valves. That is why you will see this dark colored triangle on the other side. That means the flow is to be intended to flow from this side to this side only. From the other side, the dark colored valve is shown, that is indicating that it will obstruct the flow from the other side. So how it will obstruct? So depending on the type of check valve. So you can see this is lift check, either it is a screw down check or it is a swing check. All will have different mechanism, but the funda is same, that it has to block the flow from the other side. Okay, so only from one side the flow will take place. You can see all these check valves have been colored on the other side, and on the suction side, on the inlet side, it is open, on the other side it is closed. So how it happens? So maybe if I take an example of a normal screw down stop check valve. So lift check valve will have different mechanism, screw down check valve will have different mechanism, swing check valve will all have different mechanism. Purpose is same, to not allow the disc. So the valve has got a spindle and a disc. In a normal stop valve, which is a non-return valve, how do you make a valve non-return valve? You will disconnect the spindle with the valve disc. Okay, so whenever you are closing the valve, the spindle will go and push the valve will close. And if you are opening the valve, the disc is free. Okay, so disc is free to operate. What will happen? The flow is as such that from one side the water or any liquid will go and push this disc up. As the disc is pushed up against the flow, and you can see, I'll draw it like so. This is the disc here, and the flow is somewhat like this. So this is the disc not connected to the spindle, and flow is somewhat like this. So when say flow is coming from this direction, it will lift this disc and go into this side, but when from the other side it is intended to come, the disc will block. So it will, the flow from the other side will put extra pressure on the disc itself, which will close the valve rather than opening the valve. Okay, because it is coming from the uh, top side of the valve disc. So that is somewhat the funda of uh, non-return valve. Normal screw down type stop check valve or the non-return valve is. But let us see the diagrams of this lift check valve, uh, swing check valve, or other check valves. How do they look like? So if you go into the diagrams part, so this is how a swing check valve will look like. This is how a lift check valve will look like. Okay, so lift check, basically you must have seen this one in many places on board, like your sewage systems. So that basically means that from the other side the valve will not allow any fluid to flow back. So you can see, if it would have been a normal glow valve, okay, screw down non-return valve like this, so you can see there is a flow orientation. So from this direction you can see the direction of flow is given in this way. 100 mm is the bore diameter. Okay, so the disc is somewhere here. The flow from this direction is pushing up the disc and going into this direction. If there is any flow from the other direction, the this side this side will go, and this is the return line. Okay, so this side will go and push this disc down, so thereby there will be no flow towards this side. So there will be no flow towards this. How do you identify? So how will you identify a non-return valve? Any non-return valve will have a cross mark on the wheel. Okay, on the wheel you will have a cross mark on the spindle. Okay, or sometimes it is given like a dashed mark, or some mark will always be there on the spindle. So that is how you will identify the non-return valve. So this is a normal screw down type non-return valve. If you see, this is a lift check valve. In the sewage systems, etc., you will have this kind of lift check valve. How it is working? It is working on, not on the principle of the spindle. So you can see when water is or any fluid is flowing from this side, it is pushing up against the spring pressure, not the not only the disc pressure. It is, that is why it is called lift check. What it is doing, it is pushing the disc against the spring pressure, and then when the flow is more than the spring pressure, when this flow is more than the spring pressure, this disc gets lifted up and the flow takes place in the other direction. On the reverse direction there is always a blockage, because this disc will be closed. Okay, that is the funda of lift check. Swing check valve, you can see, swing check valve is like this. Okay, swing check valves are generally used in the overboard lines of the sewage system, and then grey water system, like this swing check valves. Okay, so how they are working generally, you can see the flow is simply in this direction. It will, flow will lift this disc. So it is called swing check, because uh, the disc is able to swing on the other side. It is not lifting. The disc is not lifting, but rather it is swinging. How it is swinging? Because the disc is hinged to a component to the assembly. Okay, you can see the disc is hinged here. The disc is hinged here, and it is like able to swing on the other side like this way. So when the flow will come, it will push this disc to swing up, and the flow will be completed from the suction to the other side. And from the, rather in the reversal direction, this disc will be closed. As you can make out from this photograph itself, that when the flow comes from this direction, the disc will be closed, it will not allow to swing on the other side. Okay, the swing can only take place in one side. So this is how this swing check valve works. You can see in this diagram also. Okay, so from the flow direction in this direction, the swing will lift the disc and flow will complete. On the other side, it will be blocked. So this is how the check valves are working. Either it will be a screw down type non-return valve where you have got a wheel and a spindle, or it will be a spring loaded lift check valve which is pushing against the spring pressure, or it will have a swinging disc which is hinged on the valve assembly itself. So these are the check valves. Okay, so all check valves, non-return valves, you can identify in the pipeline diagram through this symbol, through the black symbol. Okay, so if any valve is having a black symbol, that is an indication it is a non-return valve. Non-return valve, check valve, non-return valve, and the mechanisms will be different. Either it will be a screw down type, or a lift type, or a swing type. Okay guys, okay, चल उसके आगे there is a pressure regulating valve. You can see in this example also, the yard maker has shown that you can see the pressure has been reduced. 40 k is, I mean 40 bar, and it has been reduced to 20 k. Okay, so pressure reduced due to the reducing valve. So on the, when the valve is placed like this, on the smaller side of this valve you are having a greater pressure. Higher pressure is shown on the smaller side, and the lesser um, pressure, say the pressure reduced pressure, has been shown on the other side, as is shown in this diagram. How does a pressure reducing valve look like? Let me just show it to you. So this is a pressure reducing valve or a pressure regulating valve. Okay, you will find it mostly in the, say, air systems. Just near your air bottle, if you take a round, your control air block is there. There you will find this kind of pressure regulating valve. Others also you can find in the fuel oil system, where you will maintain the pressure. Okay, to maintain the pressure in the line, you will find this kind of regulating valve. Basically these are diaphragm operated. Last day we had seen the diaphragm operated control part of a valve. So this is how this diaphragm operated valve works. It is spring loaded on the top, and it is operated on the diaphragm principle. This has been set at a set pressure. Okay, so it will only allow the liquid or air to pass only on the set pressure, because the higher pressure it will obstruct and let reduce the pressure down to certain level. Say if you are using in the air manifold, it will use to reduce the pressure from 30 bar to 7 bar. Okay, so basically by increasing the area, the pressure is reducing on the one side. Okay, and by allowing only the flow in the say set pressure, only the set pressure will be allowed to pass. So this is a pressure regulating valve. uh, okay, pressure regulating valve you will find in the fuel oil lines, in the lube oil lines, in the starting air line. Okay, near the starting air bottle you will find in the control air manifold this kind of valve, which is used to reduce the pressure or regulate the pressure. Okay, next is safety valve or relief valve. It's a very common valve. Mostly what we have to see in this during the studying the pipeline diagrams is, whenever you have a spring on the top, Okay, that means it is spring loaded. Okay, it is working on the spring load, it is working against the spring pressure. Okay, so if it is a safety valve, yeah, either it is an angle safety valve or relief valve or a normal linear safety valve, you will have this type of spring on the top. Okay, uh, that is how you will differentiate. And between the safety valve, relief valve, or a self closing valve. Acha, what is a self closing valve? Self closing valves you must have seen in your settling service tanks, na? In the drain line there is one valve which you will press by uh, foot or hand, then it will open the drain. Otherwise, as you leave it, it will just close by the spring pressure. So that is called the self closing. How will you differentiate in the pipeline diagram between a relief valve and a self closing valve? You can see there is a dash on the top. So this shows a handle and a spring, whereas in the safety or a relief valve you will not have a handle on the top. This handle is missing. Okay, let me just show it to you in the photo. So safety or relief valve, we are aware it is fitted on the numerous places, like your boiler safety valve, starting air compressor has got a relief valve. In all the lines, you will find a relief valve. Starting airline you will have a relief valve. In the air bottle you will have, so number of places you have got the application of the relief valves, that you will see in the line diagram also. This is an angle safety valve. It is used against the set at a pressure to lift against the spring pressure. Okay, the spring is set at a pressure, so the boiler will only lift, the safety valve will lift in the boiler only when it is rising against the uh, set pressure. Okay, so that is what a lift safety valve looks like. What is a self closing valve? A self closing valve is this one. You must have seen this in your settling or service tank drains, etc., or any other like lube oil tanks, other tanks drains. So it has got a handle which is connected with the spring mechanism. So when you press this handle, the lever goes down and the valve opens, and as the user is leaving it back, the spring retracts and the valve lifts. So that is self closing. If you have to open it, you have to open it by manual pressure. So that is self closing valve. Then comes the regulating valve. Regulating valve is similar to the pressure regulating valve. Regulating valve is similar to the pressure regulating valve. Pressure regulating valve is basically used to reduce the pressure. As we can see in the example, it is reducing the pressure from 40 k to 20 k. But regulating valves are just to maintain the pressure. So the simple difference here is, you can see the orientation. You will have a small triangle and a bigger triangle when you have got a pressure regulating valve, indicating that there has been a change in pressure when you are using this type of valve. Small triangle and a big triangle. Okay, small triangle followed by a bigger triangle. This is higher pressure side, this is lesser pressure side on the other side. Okay, area increases, pressure reduces. P1A1 equal to P2A2, continuity theory, right? So as the area increases on the other side, the pressure reduces. So that is how you get a lesser pressure on the other side. So that is also indicated in the diagram, small triangle and a bigger triangle. But in a regulating valve, you just see an arrow from the top. That means the one that I had shown to you, the diaphragm operated one, this can be called a regulating valve also. So this is used in, say, steam line or fuel oil line to maintain, say, 8 bar pressure you have to maintain. So it will not allow the pressure to increase more than this. Okay, this pressure. So it will just regulating valve with a spring load or something like that on the top. You can see it is shown with a arrow. That is a regulating valve. Okay, butterfly valve. Okay, very important here is to note, that people often get confused, है ना, कि between a stop valve and a butterfly valve. In the line diagram, how will you identify that it is a butterfly valve? The butterfly valve will always have a double dash like this. You can see here double line. So this double lines indicate that it is a butterfly valve. Okay, butterfly valve, how it looks like, I think you all of you must be aware of. So this is how a butterfly valve will look like in actual. Okay, the either it is a handle operated or wheel operated. Basic function is that this wheel or handle will turn the disc inside to open or close. Okay, so that is a butterfly valve, very commonly used in engine room. All the big valves etc. in the seawater pipeline etc. you will find it butterfly valve, easier to operate. Okay, uh, next is the gate valve, common valve. uh, Only thing is it is being indicated uh, like a black dash and a T on the top. So basically what it is indicating is that the gate valve is closing the disc and the seat. So the spindle is connected to the disc and the gate valve is used to manually close the valve. So you will have the spindle connected with the seat. Okay, screw down type gate valve. Then there is a breather valve. Breather valves are generally used in set um, on the tank escape, like your PV valve is a breather valve. Okay, so PV valves are like breather valves. So this is indicated with a dot and a square in the dot. So breather valves are basically to release out the excess pressure. So in the tanks etc. you can find this kind of breather valve. Okay, the purpose is basically to release the excess pressure. Okay, the next is a cap valve. Hose cap valve means there is a cap fitted on the valve. The basic purpose for this type of valve is, say if you are using it in the airline. In the airline you must have seen it has got caps. Why these caps? So that on the other side if you are using say it for an air hose or something, uh, so that you can open the cap and you can fit the connection for the hose etc. Okay, so this cap is there put in place in the fire hydrant line or in the air line, so that even if the air leaks out it is retained in the cap, or the water leaks out it is retained out, or the valve leaks, the air does not leak out in a huge quantity or somebody does not get hurt by this air. So this is a hose cap. By this cap is given, this cap is removed and you use your coupling for the air hose or water hose or something like that. Okay, so that is why it is called a hose cap valve. Numerous purpose in the engine room you will find at the service locations this kind of hose cap valves for air service or water service. Okay, or steam service, this kind of hose cap valves will be always be there. Okay, next is needle valve. Needle valve and V port valve, both are different kind of valves, but the indication has been shown as same. Okay, a needle valve is indicated with a needle on the top like this. Okay, so needle valve basically are the precision valves. The purpose being, uh, anywhere if you are using for accurate throttling, say in the control air line or in the say any water line or anywhere, if it is used for accurate throttling, this kind of valves are used. Okay, you can see the size here of the hole is very small. The purpose here, when you are opening or closing, the amount of flow can be controlled in a very precise manner. That is why these needle valves are used. Okay, the needle valves. And V port valves, if I show it to you, it will have a say it is just like a ball valve. The funda is that there is a V notch cut in the ball valve. So as you will move this ball valve, there can be a flow regulation through this notch. Okay, flow can be controlled by opening or closing of this V port in the ball valve. So it is just like a ball valve with a V notch on the ball. Okay, that is called the V port valve. Indicated, both are indicated, needle valves and V port valves are indicated by the same symbol. Now what is a cock? You can see this one being used in, so this is also one type of cock. This is a cock, you can see air cock or any water cock used for uh, flow control regulation. Small valves generally are used in this cock, like your control air lines, you will find this kind of, or small water lines, these cocks are there. So this is a cock valve or a cock simply. DN15, this is showing that nominal dia and the flow direction. So both the things will always be indicated on the valves when you will see it. One is the flow direction. Okay, this is shown in the flow direction, and the DN15, that is the nominal diameter of the valve. Okay, so 15 is the nominal dia of this valve, of this cock. Okay, now next one is a three-way cock, which is L port or T port. So we'll understand one by one what is L port, what is T port. Okay, so if you can see here in the three-way cock, let us see, this will look like this three-way. Okay, so this is always three-way. You will have either A, B or C. If it is an L port, your flow will be controlled from A direction to B direction, or at that moment your C will be blocked. Okay, or from C direction to B direction, at that moment your A will be blocked. Where this type of L port valves are used, generally when you are doing changeovers, say this is a fuel oil, this is diesel oil. So fuel oil will, when your changeover valve is operated, your fuel oil will flow from A to B, because uh, B is the fuel oil line which is going into the system. Okay, so if you are using fuel oil, the valve orientation will allow from flow to take place from A to B. If the say changeover has taken place, this side will be blocked, and from say DO side, from C, the flow will be taking place to B. I hope you are getting it, guys. The flow will be taking place from C to B. Okay, C to B. So that is an L port three-way valve. Okay, indicated like a L shape in the three-way direction. You can see this one with an, so you will have three triangles as a normal three-way valve. Okay, and the port will be like this. So this is a three-way cock, small valve. So this one, three-way valves are bigger valves that we had seen earlier. This is like a three-way cock, small one. Okay, small like this, three-way cock. And then there is T port. T port means, if there is a T port in the same diagram, if you understand what is a T port valve, don't go by these plugs. These are just shown for, like new valve is there now, so the plugs are there. This is not any indication. The only the mechanism inside, the ball inside which is turning, is responsible for changing the flow direction. Okay, if we take it as a T port, in the T port what will happen, there can be flow from this side to this side also. Okay, this side to this side, this side to this side. So that makes a T. Okay, flow from this direction to this direction and this direction to this. So it can be in the perpendicular direction, it can be in the linear direction also. So how it is used, if it is a T port, say in the bypass arrangement, you want to bypass something, little bit of this one will open on the other direction, will let the flow to take place from one side to the other side. Okay, say if you want to bypass 10%, so you can open the valve little bit, it will flow 90% flow in this direction, 10% in this direction. That is T port valve. Okay, and in which the same fluid is flowing, say if the cooling water is flowing or steam is flowing, that it needs to be regulated, you can use a T port valve. If it is only to isolate the two mediums, like different mediums are flowing, fuel oil and diesel oil flowing, you are using a L port valve. When your same medium is flowing, you are using a T port valve. Okay guys, I hope you understood the concepts here in the valve and cock system. So this will help you when we are reading the engine room pipeline diagrams. All the valves will have their specific purpose when they are installed in the pipelines. Okay, thank you guys.